Wow, it's such a pleasure to be here. This is my first time on JSHeroes, hopefully not my last time, and I'm enjoying it so much. Are you enjoying the conference? Yeah? Yeah! Okay, so I'm here today to talk with you about API mocking and web standards, and how you can even put these two in a single sentence. But first things first, my name is Artem. You can find me as Ketenaito almost everywhere on the web, including my website at ketenaito.com. And you may also know me as the author of this tool called Mock Service Worker. So in essence, Mock Service Worker is an API mocking library. It allows you to intercept requests and mock responses, very simple. And this problem space is not new at all. There's been dozens of different solutions in JavaScript to tackle this, so why build another one? Well, the core point of MSW is to advocate and promote API mocking as a standalone layer. Because if you think about it, you can reach out to mocks for different purposes. Let's say, of course, you're testing and you want to mock some HTTP calls to establish proper test boundaries. You use API mocking. Let's say you want to demo something for your team or your stakeholders, but the API is a little behind or maybe buggy, who knows. And you reach out to API mocking to augment it. Or maybe you're just doing some storybook showcase and use it there too. So what ends up happening, you have a bunch of different tools. And most of them even ship with their own API mocking capabilities. But the problem is, they kind of speak different languages. They don't understand each other, they can't communicate, and there's so little you can actually reuse. You end up repeating yourself over and over from tool to tool, but all you wanted is to describe network. And this is what MSW does. It lifts this API description, this network description up, and then it integrates into each particular tooling. And as a cherry on top, it does its interception without this nasty global patches like fetch. I actually wrote a nice article about it recently about why you shouldn't patch globals. You can head to ketenaito.com and read it. I think it's really insightful. And instead of doing patching, it relies on the standard web API. Because turns out there's already existing means in JavaScript to intercept requests. And those means are the Service Worker API. Granted, it's designed for caching, but we were able to repurpose it to act as an interception mechanism, and it worked just nicely for years. But OK, this is all fun. But how do you actually mock request? How do you describe that network? Well, you use these functions called request handlers. In very simple terms, it's a function, and it controls which requests to intercept and what responses to return to those requests. Very simple. Here's an example of a request handler. So it's a handler for the post endpoint, for the post method of a user endpoint. So whenever this request happens in your app or in test, this callback function gets called. This request response context as an argument, and the responsibility of this function is to produce a mock response. So here, what we want to do when we pass to the user, we want to read the request body as JSON. And MSW is trying to be smart about it, and it's going to look up the headers of your request, the content type, and if it's JSON, it's going to automatically parse it into an object for you. And you can access the name property on it. And let's say for this handler, we want to return a mock response. So we call the response composition function, and we provide it with a bunch of utilities, that context. So in this case, we want the response body to be JSON with this particular name property. Very simple. Now, what I like to do, especially with third-party tooling, is do this little fun exercise. So I take a very primitive example like this one, very basic, and I remove every single bit from it that's not standard JavaScript, right? So let's do just that right now together. So ready? Yes. Yeah, there's nothing left. Because everything we saw on that example was an abstraction. So res.post is an abstraction. It's just some made-up custom function that only exists in the universe of MSW. The same with this request response context call signature. Nowhere else on the web you actually use the same call signature to handle any request. And response composition function, it's some functional programming composition. Who even uses that in JavaScript, right? And then you have the context utilities. And again, completely contrived API you have to learn. And the thing is, this API has been working without problems for years, for 5 years. And it helped people achieve their goals. It helped them describe the network and test better. And you may say, well, if it's not broken, then why bother? Just don't touch it. I don't agree. Actually, I think in the open source world, at least, there is a much better rule to follow. If it's not educative, don't ship it. Because you see, my responsibility as an open source author is to, of course, give you the tools to achieve your goals, but also make sure that those tools make you a better developer. Because I want you to learn the language you're using and writing and not just some particular third-party libraries. That's the point. And it's not just my opinion alone. It's so evident if you look at the directions that major JavaScript frameworks are taking, like Next.js, React Router, and basically everything. Everybody is betting on web standards because this is the way forward, and they are actually pretty powerful. And it's just so happened that MSW has gained a huge adoption, gigantic, like more than 100,000 repos on GitHub and more than like 3 million downloads a week on NPM. That's so many developers. That's like hundreds of thousands of developers having to go through the docs, having to get familiar and memorize all these custom abstractions, having to figure out how to use them. That is such a great price to ask. So about 2 years ago, I decided that that's a problem. We need to make it better. We need to improve the educational aspect of the library that's so used. And one of the core philosophies I have in designing software is that, for example, when you're mocking the network, you should really do it in the same way that you interact with the network, outside of mocking. So in the browser, for example, you're most likely using the fetch API. I'm pretty sure every single person in this room has done a fetch request at some point. It's a fantastic API. It's easy to use. It's awesome. You may be also using XML HTTP request. Also a great API for some situations, and it works flawlessly for decades. And now in Node.js, especially from 2 years ago, it's been a little tangled. The main way to make an HTTP request in Node was the built-in HTTP module, which probably most of you never heard about, and for a good reason. It's extremely verbose. It's hard to work with. It's just a pain, to be honest. So you probably used third-party libraries like Axios, GOT, Request that were relying on that native API for you. And I've been dealing with request interception in Node.js for about 6 years now. And if there's one thing I learned from that experience, is that there are more ways to make requests to nodes than there are stars in the sky. And I wish that was a metaphor. Because once you dive into the user land and into what people publish to NPM, you encounter all sorts of chaos. Like somebody's following the docs. Somebody's following the docs from 3 years ago, from 10 years ago. They're combining options in different patterns and relying on JavaScript being this kind of dynamic, untyped beast to figure out what they want. It's really hard to accommodate for all of that if you're building an environment and client-agnostic tool, which is MSW. Nevertheless, we try to do that. So we try to take all that variable input, the ways you make requests, so for example, HTTP client request, XHR, fetch, and we try to bring it to the common denominator. And we introduced this concept of isomorphic request and isomorphic response. And it worked for some time, but it was a terrible idea because then people started wanting some convenience features. Well, can I read this request body as blob? Maybe form data? Can I send a stream somehow? Hey, can I cancel this request? There's this thing called a board controller. And we had to implement or try to implement all of that to match the experience, the expectations that developers had. It was a mess. And by that time, I was about 4 months invested into this rewrite. And honestly, I was just losing hope in humanity. And then something incredible happened. Node.js 18 got released. And it was insane. I think this was the moment when my kind of desire to program was rebirthed, because Node.js 18 was a fantastic release. Back at the time, we promised compatibility with version 14 and 16, but version 18 changed everything. I decided to scrap my work and start from scratch supporting Node.js 18 as the minimal version. But why? Because it introduced one of the most impactful features, at least for me, the fetch API. And yeah, I'm talking about the same fetch function you've all used in the browser. Now you can use it in Node.js. And it's not only that function, but also a bunch of other APIs introduced by the fetch API spec: readable stream, request, response, headers, blobs, form data. And if some of those are not directly from the spec, they were made much easier to use through the fetch API. It was insanely crazy, like cool. This was the moment when my light bulb went up, and I thought, yes, this is the common denominator we want. The same way, the same API to represent the network both in the browser and in Node.js. So I set up to work, and I employed one of my favorite engineering practices, throwing code away. And like thousands of lines of code later, and like implementation thrown out of the window and documentation also, I arrived at this new API, MSW 2.0. And it's been live for a couple of months now. And here's the gist. It's the same example as we saw before. So it handles the post request to the user endpoint, and then it has a callback function. But notice now, there's a different call signature. We just have one argument. It's an object, and it has this request property. And you may be wondering, like, what is that abstraction over? So let's see. We want to read this requested JSON. So how do you do that on the web? Well, you call request.json, and you await that promise. And that's exactly what we do here, because this is the same fetch API request instance, literally the raw request representation that your app made. And if you want to return a response, well, how do you define responses on the web? You use the response class. So here we're using the static JSON method on the response class to produce a response, JSON response with this name property. The same behavior, and let's do the same exercise, throwing away everything that's not standard JavaScript. Okay. Now, granted, some things will always be contrived. This is the contract you have to make with your consumer as a library author. For example, the request matching, it doesn't really belong in the browser. It's more of a Node.js server thing, so that's OK. But take a look at the heart of this handler, at the main logic, what we want to do with the request, what we want to do with the response. This is standard JavaScript API. You probably have seen and done this multiple times. And when we rolled out this API and people started using it, one thing became apparent is that by relying on the platform, by using the platform, everybody wins. And I'm talking both about developers and also maintainers who write those tools. So developers obviously win because they have a shallow learning curve. Suddenly, you don't have to go and spend hours in the docs kind of blaming this author for designing such a convoluted API that I need to remember. No, MDN or the spec, and that is everything you probably already worked with. That's such a joy to use. And you're getting features for free. Well, you want to respond with a stream, construct a new readable stream, push the data to the controller, and create a response with that stream, and that's it. It's very simple, and it's free, no abstractions. And of course, you're just getting better at JavaScript. You're interfacing with these APIs more often, and you become a better engineer as the result. It's amazing. For maintainers, it's a very similar story. We have less code to write. It's so nice when you don't have to contrive this custom classes and functions, but you can just globally get them from the platform, from the place where they're defined and abiding the spec. We get the compatibility, because if one tool relies on the spec, suddenly, if there's another tool that does the same, you can reuse the logic between them. You can do more. You can have less friction between different tools and setups, especially, like I mentioned, when you reuse the network across different kind of tooling to achieve the same goal effectively. And of course, we as maintainers also need to learn. We make mistakes. We need to get better. And one of the ways to do that is to interact more with JavaScript, with the actual language, with the APIs it provides us. So the APIs we design ourselves can be modeled after them. So they feel like an extension to the language, not kind of like replacement. OK, and I have a story to tell you. This is a real story that happened with me like 2 weeks ago. So here I was minding my own business in a foggy afternoon. And I was scrolling Twitter, and suddenly one of my friends, Julius, just writes me a message. They're working on Upload Thing, by the way, really cool stuff. And he writes me a message, hey, so MSW is broken. Like, our tests are red. What gives? And of course, as a seasoned open source maintainer, I approached this with like proper ethics, and I said, you have no proof. And turned out Julius had proof. So he sent me a screenshot of the failing CI where there was this exception. Could not convert argument type symbol to string. Cryptic messages, love them. And somewhere in the stack trace, there was a pointer to MSW, to one of the libraries. So I had to look into this. And turned out the error itself didn't surface through MSW, but it actually tried to create a request. And this request in it is a function from Undici. Undici is the official fetch API implementation in Node.js. So we tried to create requests, then something tried to create headers, also from Undici, and then the error happened. OK, so the problematic area is looking like to be Undici. So we went to GitHub, and we opened an issue. So we described the problem, and then folks from Undici jumped into the issue very quickly, and they helped us discover two things. First thing, we were using it wrong. So the code that Julius had in the test, he was constructing a headers instance, and then copying it by spreading the headers object, but basically the headers instance, into another object. But turns out, headers are not iterable. So this will return an empty object, no matter how many headers you have. And instead, we should have just created entries out of headers. So this is an honest mistake. We laughed about it. This was an easy fix. But there was also another issue we discovered. Node.js had a bug. Because when you spread a headers instance, you get an empty object. An empty object, not an exception. And turned out that internal implementation of Undici of the headers class, they were using symbols for some internal stuff. And when they were spreading the instance, when you spread the header instance, it copied those symbols somehow incorrectly, and it broke Node. So they opened a PR very swiftly that migrated from using symbols to using private properties to fix this problem for everybody in Node.js. So what is the moral of the story? The developer discovered that they were doing something wrong. They were using the specification that the globals wrong. And the Node.js, the platform, discovered they were implementing those globals wrong. And let me make it abundantly clear. This was only possible because, and you expect me to say because of MSW. No, it had nothing to do with MSW. It was possible because the developer was exposed to the standards. They were using the platform more. And if this is not an example how, by using the platform, literally both sides, everybody wins, I don't know what is. So if you're excited about MSW, never used it before, give it a try, npm install MSW. It's effectively a tool to control network, not only for mocking, you can observe the network, monitor it, log it, augment incoming traffic, and of course use it for testing and for mocking as well. If you want to learn more, head to mswjs.io to learn more about the project's philosophy, mission, APIs, best practices, and so forth. This is a fantastic place to start. Now, before I go and we go to coffee break, I have one more important thing. So this January, I was extremely lucky to join Epic Web alongside incredible industry-leading developers like Kenzie Dodds and a bunch of other instructors, where my job would be to teach all of you about automated testing. And as I'm working on all of that materials, I encourage you to check out epicweb.dev, and you can even scan this code to go on one of my articles. It's an introductory article called The True Purpose of Testing. And I'm pretty sure for some of you, it's going to be an eye-opening article. So why do we test? There is actually a very clear answer there put in the article, so give it a read. Thank you.